Hello students, Sean McMahon here. So in this video, we're going to talk about basic atomic structure. And I'm pretty fortunate nowadays, most people know some basic concepts with atomic structure. So for example, many people know that the electrons are negatively charged. And what we're seeing in this, you know, model of an atom, the nucleus is where the positive charges are. Now, if you were to grab a periodic table and you were to look, you would see lithium has a number 3. And the reason why lithium has 3, it has 3 protons. So these red circles are representing the positive charges that we find in the nucleus, protons. And in this particular atom of lithium, it also has what are called neutrons, and it has 4. So this number here represents the number of protons, and I'm just going to write number of protons as number of P positive. That's kind of a symbol for protons. And there's usually another number, and for this case, we'll put a 7. And this number right here is the number of protons plus the number of neutrons. And we'll see later that this number here is referred to as the atomic number, and this number here is referred to as the mass number. So I'm getting ahead of myself, but basically this is talking about the basic structure of the atom and the subatomic particles found in them. One of the things I wanted you to notice is to look at how small the nuclear diameter is. 10 to the minus 15 meters. That's a femtometer. That's incredibly small, okay? So as we move forward, what is the structure of the atom? Basically, it has a nucleus, and the nucleus contains the positive charge because it has protons. The nucleus also contains neutral neutrons. So in the picture I described earlier, if I took the element lithium, so if I grabbed lithium as a metal, pure lithium, if I looked at it at a microscopic scale, it would just be a bunch of lithium atoms. That's what those spheres represent. But if we look deeper, what it would really represent, it would represent that it had the 3 protons in the nucleus, the 4 neutrons, and circling around that nucleus are 3 electrons. Why is that? Because the 3 positive charges have to be canceled out by the 3 negative charges from the electrons. And why is that? Because all elements, all atoms are going to have a neutral charge. They do not have a charge. Atoms never have a charge, neither do molecules, okay? We'll talk about charges when we discuss ions. Ions have charges. Atoms do not. They are neutral, so they have the same number of protons and electrons, like these lithium atoms. They have 3 protons and 3 electrons. And again, the electrons are basically the majority of space in an atom is empty space. So you can think of it as, for an example, a lot of people talk about the solar system, right? The center, you can think of our solar system as the sun. That would be the dense nucleus. And all the planets orbiting around the sun could be considered electrons. But the majority of the space in the atom is empty space. So the majority of it is empty space, and the electrons are outside of the nucleus. That's the main purpose of this video, is for you to understand that. Now, there is atomic mass. So the problem with atomic mass is, well, it's a really small number. So the first thing is, if you took atomic mass and you looked at, 1/12 of a carbon-12 atom. The reason why they do carbon-12 is carbon-12 have 6 protons. So it has 6 protons. And remember, that number there is the number of protons and neutrons. So it also has 6 neutrons. So it's kind of an even number, 6 and 6. So they divide it by 12 and they get what's referred to as 1 AMU. An AMU is an atomic mass unit. Now, we'll talk about later how the atomic mass unit is an incredibly small number. fact, it's pretty much 1.66, and there, I don't memorize it, but it's basically 1.667 times 10 to the negative 24 grams. Now that's an extremely small number. So the mass of carbon is 12 times that. It's basically 12 AMU. But it's a lot easier, instead of saying or punching on your calculator 12 times 1.667 times 10 to the negative 24, get that number and say it. It's easier to just say, oh, carbon, it's 12 atomic mass units, 12 AMU. So the key is a proton has a mass of about 1 AMU. A neutron has a mass of about 1 AMU. That's why carbon-12 has 12 AMU. Now electrons, and people get confused, electrons definitely have mass, okay? They're matter, they have mass, okay? We don't account for their mass because they are so much further down, if you look on placement value or precision. So if I was to add the mass of one electron, right, to one proton, I go to the least precise. So this mass is pretty much negligible when I look at it. It's basically it's roughly 1/2000th of an AMU. So when we're figuring out the mass of atoms, we kind of don't look at the electrons. They're negligible. And it's not to say that they don't have mass, but their mass isn't that significant. So I always like to use the analogy. If you had an elephant on a scale that weighs tons, right, 2,000 pounds, an elephant several tons. If he's on a scale and it only reads in tons, and it says he's 4 tons, if you throw a flea on his back, that scale's not going to move. Why? It's not to the precision all the way down in that placement value. It's reading up here. So throwing a flea on an elephant's back is negligible to his overall mass. The same concept with an electron. Its mass is negligible to the overall mass of an atom because the majority of the mass, or all of the mass, pretty much the majority of it, is in the nucleus, and it's contributed by the mass of the protons and neutrons. So the big takeaway, couple symbols, protons, P with the superscript of a plus. Why? They're positively charged. Neutrons, N with the superscript of a 0. Why? It's because they're neutral. Electrons, E with the superscript of a negative. Why? They have a -1 charge. My atoms that are neutral have to have the same number of protons and electrons. So like hydrogen, it has 1 proton. What does that mean? In the nucleus, it has 1 proton. And then orbiting around the nucleus is the 1 electron. So that 1 electron, right, that's outside of the nucleus, is negatively charged, and it cancels out the positive proton. So hydrogen's a neutral atom. If we look at the masses, protons and neutrons are 1 AMU. And again, it's not that electrons don't have mass, but they're negligible. And then the important thing is location, location, location. Protons and neutrons are found in the nucleus, and the electrons are outside the nucleus. Now, I skipped a bunch of early atomic models. For example, I skipped the Dalton's atomic theory, and there's videos for that. I've also skipped the Thomson model with the plum pudding model, and Rutherford's nuclear model is the one that we just covered. So Rutherford's nuclear model is what we're talking about, a dense nucleus with the electrons outside the nucleus. In the next coming up videos, we'll be discussing a few other models, which a lot of people are really comfortable with. The Bohr model, where the electrons are actually positioned in fixed orbits, okay? So that is very different from the nuclear model that I just talked about, okay? And basically, the fixed orbits are fixed in size and energy. The energy of an electron depends on the size of the orbit The closer the orbit is to the nucleus, right, the less potential energy it has. The further away it is, the more potential energy it has. And typically when we're quantizing these energy levels or these electron orbits, they are fixed in energy and they're discrete. We also use numbers to show them. So like you'll see the principal quantum number n showing n equals 1. Why? That's the first energy level. This is energy level 2. Why? That's the second energy level. So we talked about lithium. If you look at your periodic table, where is lithium located on the periodic table? It's in period 2. What does that mean? Row 2. Why? Because it has 2 electron levels. And it's in group 1. Right above here is hydrogen. Why is it in group 1? Because it has 1 valence electron. If I look, lithium has a total of 3 electrons, right? Because it has 3 protons. The first 2 electrons go in that first shell, that first orbit. The third electron can't fit in that orbit, so where does it go? It goes in the second energy level. And where is it? It's in group 1A, the alkali metals, and the alkali metals, group 1A, have 1 valence electron. That's what they all have in common. So that's what the Bohr model does for us. And then as time goes on, we'll also discuss the better model, which is the quantum mechanic model, because we'll see that the Bohr model has shortcomings. It works excellent in quantizing these energy levels and calculating them for single electron species. Doesn't do so well when there's multi-electron species due to shielding, penetration, and Coulomb's law, other issues. So that's when we will have to go to the more widely accepted quantum mechanics theory, which talks about instead of these fixed orbits, we have what are called probability maps, which are orbital models, where the density of the dots shows the likelihood of finding an electron in a certain region of space. That is a wave function, and that's basically what the orbitals in the quantum mechanic models describe. But again, I'm getting ahead of myself. For this particular video, all you really need to know for this particular video is this. You just need to know that the subatomic particles, right? There's 3 of them: protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, electrons are negative. The masses for the protons and neutrons are 1 AMU, so the majority of mass is found in the nucleus, and the electrons are outside the nucleus, and their mass is negligible. So I hope these basic concepts make sense. I'm excited to teach you the more complicated concepts with the Bohr model and the quantum mechanic model as we move further in the course. So thanks for watching. I hope you enjoyed the video.